Hey, welcome to lesson number 3. We're just going to be looking at quadratic functions and analyzing the graph of y equals ax minus h squared plus k. So in class we're going to go through the investigation, but just want to make sure you have these examples done. So when we're looking at the if we're looking at the graph of the quadratic equation, 2x plus 6 squared minus 9. So I'm just going to put the graph up so you can see it. So 2x plus 6 squared minus 9. And the graph. There we go. So we want to state the coordinates of the vertex. So remember, my vertex is my lowest point of the graph, and we could look up online, but we could also just say, okay, well, it's at 6, -6, and -9, which is also what my h and my k values tell us, and this is what we're going to be looking at tomorrow. So my coordinates of my vertex are -6 and -9. Our axis of symmetry, that's the point where if I split it down the middle, the one side will be equal to the other side. My axis of symmetry is x equals -6. Do we have a maximum or minimum value? Well, in this case, it's opening upwards, meaning we have a minimum value. And the minimum value is equal to the lowest point of my y value, which is y equals -9. My domain and range of the function, well, x is an element of real numbers, but so that's my domain. My range is going to be y has to be greater than or equal to -9, such that y is an element of real numbers, since I had a minimum value. And we want to determine the y-intercept of the graph. Well, all we need to do to find the y-intercept, we know that x is going to equal 0. So y is equal to 2x plus 6 squared minus 9, where I plug 0 in here, plus 6 squared minus 9, and we're going to be left with 2 times 36 plus 9, and 72 plus 9, we're going to be left with 81 is equal to my y-intercept. Now we want to graph, make graphs of the following. With two x-intercepts, we could have a graph that looks something like this, where it's crossing twice. With one x-intercept, we could have a graph that is just touching my line once, and no x-intercepts, we could have something like this. And we'll talk about the equations of these lines in class tomorrow and what they could potentially be.